Hello, and welcome back to Shiksha Costa. Today we're going to learn about something called the sum product rule. The sum product rule is going to teach us how to factor a quadratic expression, which is in standard form, if the value of a is 1. In other words, if you only see it start with x squared, then we're going to learn how to factor that today. To start off, expand and simplify these three binomials right here. And you should know how to do that if you've been learning how to use the technique which some people call FOIL. So pause the video here, expand all three of these, but in your answer, please make sure you include an area model. Okay, well hopefully you were able to do that, and if you weren't, please just watch as I do the first one, and then maybe you can pause the video after I'm done that one and move on to the others yourself. So for this first one here, the way we expand the product of two binomials is you take the first two terms and you multiply them together, so x times x is x squared. Then the outer two terms, x times 4 is 4x. Then the inner two terms, 3 times x. And then the last two terms, 3 times 4. Now that we have this expression here, we can recognize that the two terms in the middle are like each other, and therefore we can combine them by adding their coefficients 4 and 3 to get 7x. Now, to create an area model out of this, I have to be able to look at these two and imagine them as two sides of a rectangle. So one side would be sort of x, which is an unknown length, plus 3. So I might draw that just like this using algebra tiles, where this is a length of x and this is a width of 1, so this is an x tile, and this length of x is really all I care about, because once I combine it with 3 unit tiles, that would be like plus 3. And if I add, if I want to show x plus 4, so this is the length, the width is x plus 4, I could do something like this. Again, we have a length of x, and then 1, 2, 3, 4. And the product, when we multiply these two, remember when we multiply length times width, we get the area. And so my final rectangle that will be in this space should be, the algebra tiles there should represent this exact quantity right here. And I'll show you how they do that just now. If I take this tile, if I'm looking for just this space right here, a tile can fit right into here, and the area of that tile would be x squared. Notice that this has a side length of x and another side length of x, right? The length and width are both x, and x times x gives us x squared. Down here we have the length of x, and we might add a tile here that has a width of x and a length of 1. And that tile would look exactly like this, and it would repeat for, of course, these three spaces right here as well. And so all of these tiles have a width of exactly x. They do have different lengths, right? This is a length of x, a length of 1, 1, 1. But we know that we can find the area of them just by multiplying length times width. Over here, I'm just going to add some more tiles, right? So this is length of x times the width of 1. X times 1 is just x. And actually, these tiles have the exact same area as these right here, right? I could take this and I could rotate it and put it right here, no problem. The tiles down here, well, this is a width of 4 and a length of 3. And so the tile that will go here will have an area of 12. And so you can very clearly see that here I have an x squared tile. I have 4 x's. I have 3 x's altogether. That's 7 x's. And of course, at the end, I've got 12. So this is an area model. Pause the video here and see if you can finish these two up. Okay, well hopefully you were able to take a look at this one and see, okay, x squared plus 5x plus 3x plus 15. And of course, these two are like terms, so we can combine them to get 8x. And the area model might look like this. So we've got x, 1, 2, 3, and x plus 5. And of course, this space right here will get an x squared tile. We can put 3 x tiles down here, 5 x tiles over here, and this area is 5 times 3 has an area of 15. And that's exactly what I ended up with here, right? X squared plus 5x plus 3x plus 15. Now, for this last one, that would be x squared plus 6x plus 3x plus 18. And the 6 and the 3 obviously can combine to give me 9x. And And now I'm going to do an area model a slightly faster way because I'm getting a little tired of writing these 1, 1, 1, 1, 1 here. I'm just going to put x, and then I'm going to put a tile. I'm going to say this length is a length of 3. Now you can see on my grid paper it actually is 3 units, but it doesn't even really have to be. All I care about is making a shape here and finding the area of it. So I can say this is x and this is 6. And then I can say, okay, well, in this space would be x times x is x squared. In this space would be 3 times x. So instead of putting several x tiles, I know that that area is just going to be 3 times x or 3x. And similarly, this area over here will be 6 times x or just 6x. And finally, down here we have a space that is 6 by 3, so 18. So when you're multiplying two binomials, this is sort of what an area model will end up looking like. The addends go on the left and on the top, and then you just find the area in between, which will always separate into 4 quadrants. The first 2 terms, the outer 2 terms, the inner 2 terms, and the last 2 terms. So now I'll ask you to pause the video and complete this entire activity, this entire investigation. We did the first 3 rows, right? We found the area of a rectangle that has these lengths and widths. And what I'd like you to do is complete this, finding the area of these 2 rectangles, and then looking at what is the value of B and what is the value of C in this case. Well, ideally, you've recognized that, okay, first these are probably the easiest ones to get started with, right? B here is 7, and C is 12. Here, B is 8, and C is 15. Here, B is 9, and C is 18. And if you had trouble expanding these, please just go ahead and back up the video until you can see the method that I used to get these areas. But certainly you should have gotten x squared plus 8x plus 16, in which case B is 8, and C is 16. And for this one, x squared plus 9x plus 20, in which case B is 9 and C is 20. Now, using this, can you, without actually creating an area model or a diagram or anything, can you actually predict what the length and the width of a rectangle with this, so we have all of these areas, what if the area was this? Could you figure out what the length and the width are for that? There is a bit of a pattern here that you could look at and try and detect. And pause the video here for as long as you need to do that to predict the length and the width of these rectangles. Well, one thing to notice in this table is there is a bit of a pattern happening here, right? Notice that I've got 3 and 4 here, and 7 and 12. I've got 3 and 5, and then 8 and 15. These numbers are related. In fact, I always have x plus some number here. Now let's say that number is, I'm going to represent it with n. And I've got another number here, and that number is n. M and n seem to be related to both B and C in some way. If you haven't figured it out by now, pause the video here and see if you can. Well, hopefully you've been able to pick up on the fact that, hey, 3 plus 4 gives me 7, 3 plus 5 gives me 8, 3 plus 6, that gives me 9, 4 and 4 give me 8, 4 and 5 give me 9. So to get the value of B, it looks like I just have to add up M and N. And very similarly, the value of C here, how can I get these numbers from these two? Well, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18. 4 times 4 is 16, 4 times 5 is 20. So it seems like to get the value of C, I just multiply M times N. And so if I want to find the length and width of a rectangle with the following areas, I need to find basically what are M and N, what are 2 numbers where if I add them together, I get B, I get 10. And if I multiply them together, I get C, which in this case is 24. Think about that for as long as you need to see if you can find out what 2 numbers add up to 10 and multiply to 24. Well, hopefully you landed on 4 and 6, right? There are lots of numbers that you can add up to get to 10. 1 plus 10, 2 plus 9, 3 plus 7. You can even go to the negatives, negative 1 plus 11, negative 2 plus 12. And because that's the case, it's really, really difficult to start by looking at the two numbers that you need to add together. It's a lot easier if you think of what two numbers multiply to 24? There's not that many pairs, right? And they do also come in pairs. So for example, 4 times 6 does give us 24. But 24 only has so many pairs of integers that can reach it. For example, 1 times 24, 2 times 12. But none of those add up to 10 except 4 and 6. And so if I want to, find this, the length and width of a rectangle that has an area that can be, represented using a quadratic model, well, I need to find two numbers that add to b and multiply to c. And the best place to start with that is not with b, but in fact with c. And in this case, we found that the length and width that would create this area is x plus 4 and x plus 6, just like we have over here, x plus m and x plus n. Moving on to the second one over here, let's do the strategy that I talked about. Pause the video here if you haven't been able to finish this, and find the factors of 27, and see which two of them you think add up to 12. Well, these are all the factors for 27, 1 times 27 and 3 times 9. There's not much more than that. And you can see very clearly 1 and 27 would make 28, but 3 and 9, they make 12. And so this very easily factors into x plus 3 and x plus 9. 25, or x squared plus 10x plus 25, the factors of 25, or 1 times 25, and only 5 times 5. And so 5 and 5 definitely make 10. 1 and 25 make 26, so not that. So this will just be x plus 5 times x plus 5. Or another way to write this actually might be x plus 5 squared. Going to our last one here, the two factors of 30, and of course 30 has 3 pairs of factors, but the two that add up to 11 are 5 and 6. And so this is x plus 5 times x plus 6. So to summarize this, if you have a quadratic expression in this form, sometimes it can be factored. If it can be factored, it can be factored into two binomials, and those are x plus r and x plus s, but it's very specific that when you add r and s, they must equal b, and when you multiply them, they must equal c. And those two numbers do have to be integers. Now, if you do have a number in front of the x squared term, that does kind of throw a wrench in the works, but you're not totally out of luck. In fact, you could just factor out the greatest common factor first, and that might make your factoring of the quadratic a lot easier. In this example, we're going to factor this completely. Notice that the first thing I'm going to do is divide out the greatest common factor. So all of these are multiples of 3, and all of them have at least one x in them, so I can divide them all by 3x, and I end up getting this expression right here, right? X cubed divided by x is x squared, 3 divided by 3 is 1. 21 divided by 3 is 7, x squared divided by x is just x. And 36 divided by 3 is 12, where x divided by x is 1. And of course, the thing that we factored out, we have to include in front. Now this is one way to be the first step in factoring, certainly factoring out the greatest common factor. But now we have one of our factors that can be factored even further. We can take this and turn it into the product of two binomials. And to do that, we look at the c value, and we find the factors of that can add up to the b value. Pause the video here, take as long as you need to see if you can figure out what this factorizes into. Well, the factors of 12 are 1 times 12, obviously, 2 times 6, right? But 2 plus 6, just like 1 plus 12 was 13, we're looking for it to be 7. 2 plus 6 is 8, and 8 is not 7. But 3 times 4 gives us 12, and that actually, when I add them together, they actually do equal 7. And so, if I wanted to factor this, I could turn this into 3x times x plus 3 and x times x plus 4, just like you see here. If I were to expand this, I would get right back to where I started, but what I did was I factored this expression to get this one right here. To check if you did everything right, one thing you can do is actually work backwards. You can actually expand these brackets and make sure that you end up in the same place that you started. For example, to use FOIL, I'll multiply the first two, x times x, then the outer two, x times 4, then the inner two, 3 times x, and then the last two, 3 times 4. And when I add these together, I still have to multiply the result by 3x, right? So this is x squared plus 4x plus 3x plus 12. And of course, I only expanded these brackets, so I've got that in brackets as well. And I kept that 3x in front. Now when I want to expand this, right, well, first let me at least combine my like terms here. 4 plus 3 is 7. But when I expand this, I can do 3x times x squared, 3x times 7x, and 3x times 12. And that gives me, oh, look at that, my original starting expression. And that's how you factor a quadratic. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.